The Global Design Challenge, offered annually by the Biomimicry Institute, asks innovators to create radically sustainable human designs inspired by the natural world. Cal State Long Beach designers have participated for the past several years. We've had student teams among the finalists before, but this is the first year 2 of the 8 final projects come from the CSULB Design Department.
Los Angeles is the land of freeways. Freeways are an integral piece of the city's infrastructure and also a vastly underutilized resource. For the last 40 years, according to the International Energy Association, energy has been on a steady trajectory of upward consumption. There is no evidence of that changing, so our goal is to offset the continued use of fossil fuel used to power the grid.
Our GenRail team is comprised of Chris Sagui, Benjamin Dadeke, Roman Wyan, Ryan Janina, and Matt White.
Our process began with research and ideation. Collectively, there was a common interest in airflow. We then began to look at 35 organisms, landing on the effectivity of the desert snail's ability to cool with high to low pressure, the cockroach's ability to compress and change shape, and the California condor's adept skill at perpetual flight. Our idea is the GenRail, a self-contained, modular, scalable, and adaptive wind turbine generator. This simple device is a relocation of the windmill requiring a significantly smaller footprint and easy implementation. We discovered that there is enough airflow being displaced by motor vehicles traveling on the freeways that we could likely create a simple wind farm system to be retrofitted and installed along the highways as a meaningful, usable, renewable energy source. We pushed the numbers of potential energy outputs. We discovered that the GenRail would very likely be able to make 380 watts per hour based on the transfer of air through its turbine at an average 24 miles per hour. Using recycled plastics and simple off-the-shelf parts, we have estimated the per cost unit of the GenRail to be between $230 and $450 per modular unit. Using the cockroach's ability to compress, the GenRail will collapse and deflect vehicle collisions, just as concrete K-rails do now, making it entirely safe and expendable. GenRail generates clean, scalable wind energy at a low cost, designed for people, by people.
This is Phalanx. It's a 3-layered system that's able to cut down the amount of heat buildings absorb from sunlight during the day. Our goal was to zero in on one of the biggest contributors to global warming, the heat island effect.
The Phalanx team includes Emery Arat, Eric Asklund, Tim Enslow, Oscar Guerra, Albert Gonzalez, and Jesus Mateo. Their innovations were inspired by camels, ants and termites, wheat, and a cactus.
The camel's nasal cavity allows the camel to reabsorb the moisture back into its system. This happens when the airflow is interrupted by thin walls. To keep the whole plant cool during the hotter parts of the day, the leaves use a capillary action to pull water into them and release it as vapor, cooling down the plant and pulling the water up into the leaves at the same time. These insects create massive structures in hot parts of Africa. To survive the heat, they make thousands of small holes at the base that then allow air to travel through, cooling it down while hot air rises through center shafts, creating enough suction to pull more air in. This cactus uses its wavy pattern to create a shadow on its core, while the edges of the waves allow heat to escape, allowing it to endure hot temperatures. After sketching, plussing, and testing mock-up models, we created a prototype of our design.
I really like this design because 3 layers that you have, they are sort of working in sync and they're doing different things as well. This is supposed to be the first barrier that absorbs the heat from the sun. So it would heat up from that direct absorption of sunlight. There would be a flow of air across this structure into these holes, and once it gets hot, this air, whatever air is in here, is going to rise up. The third innovation that you have here is this capillary layer. Surface tension, it would automatically absorb the water, right? And the water will evaporate. And what that evaporation will require is a lot of heat absorption. So if this is right next to your inside wall of the house, the wall will cool down.
Our design can be implemented on existing buildings without the need for dramatic architectural alterations. This system would get its water from wasted gray water. It would allow for some of that water to run along the base of the phalanx, where a capillary mat would pull it up into its system. Phalanx is the perfect shield to defend against global warming.